So let's return to the example we had from the first video in this section. We're trying to compute the integral of e to the x squared plus y squared over the unit disk, right? This disk of radius 1. So how do we do that? Well, we use polar coordinates. So if we use polar coordinates, well, e to the x squared plus y squared, what does that become? Well, remember, x squared plus y squared is r squared. So we have e to the r squared, right? And then dA is r dr d theta, right? So r, and then actually you can decide the order of dr and d theta. That's up to you. It depends on the integral. But this r has to be there, right? And it's as in, well, in this case it doesn't really matter, but it's usually easier to do dr d theta, so let's just go ahead and do that, right? So what are the bounds on r for the unit disk? Well, remember, the unit disk is just this, y, x, where the radius is always 1. Right? So, and remember, r is always starting at the origin and going outward. Right? So it starts at 0 and goes to 1. Right? And then theta goes from 0 to 2 pi. Okay? And then now, well, can we do it now? You'll notice we can. Before, we just had basically like e to the r squared up there. But now we have this extra r. So we can do a u sub with u equals r squared. Right? So then du is 2r dr. Right? So then this integral here becomes 0 to 2 pi. Now what are the bounds on the new integral? Well, 0, plug that in, goes to 0. 1, plug that in, goes to 1. And then we have 1/2 e to the u du d theta. Right? And now we can integrate that. So I'm going to pull this 1/2 out now. So 0 to 2 pi. Integrate e to the u, and we just get e to the u, 0 to 1, d theta. Right? Well, if you integrate that, you find you get 1/2, 0 to 2 pi, e minus 1 d theta. Right? And then from here, I'm pretty sure you can get this is pi times e minus 1. Okay? So the key part to always remember here is don't forget this guy. Right? Very important. He even talks to you. Don't forget me. All right? So we'll do another example and see you in the next video.